What if the most powerful telescope humanity has ever built looked so deep into the cosmos that it found something it was never supposed to see? What if James Webb discovered galaxies that shouldn't exist, black holes appearing billions of years too early, and patterns suggesting the universe itself might be conscious? Let me tell you what I found tonight. I wonder where you are right now, what quiet corner of the world you're listening from. If these mysteries call to you, stay. A like or subscribe helps, but your presence is enough. Let's begin. Imagine the night when James Webb sent its first deep field images back to Earth. Picture the control room at NASA filled with the world's leading astronomers, all gathered around screens glowing with light that had traveled for billions of years to reach us. The room fell silent, not the comfortable silence of awe, but something heavier, something closer to disbelief. Someone whispered that the instruments must be malfunctioning. Someone else ran the calibrations again and again, but the data didn't change. What the telescope was seeing simply could not exist in the universe we thought we understood. You see, when we look deep into space, we're looking back in time. Light takes time to travel across the cosmic distances, so the deeper Webb peers into the void, the further back it sees toward the universe's infancy. We expected to find darkness there, simplicity, the cosmic equivalent of a blank canvas just beginning to receive its first brushstrokes. The first galaxies should have been small, primitive things, barely held together by gravity struggling to ignite their first stars in the cold darkness that followed the Big Bang. But that's not what Webb found. Instead, it discovered massive, mature, fully formed galaxies, blazing with the light of billions of stars. It's like expecting to find a single-celled organism at the dawn of life, and instead discovering a fully grown elephant, complex and sophisticated, already thriving in ways that shouldn't be possible yet. Let me show you exactly how impossible this is. Webb detected a galaxy designated JD's GS Z13-0, shining from a time when the universe was only 325 million years old. Now that might sound like a long time, but in cosmic terms it's barely an instant. Here's the problem that's keeping cosmologists awake at night. This galaxy contains a mass of stars that, according to our best models of stellar formation, would require at least 500 million years to accumulate. The mathematics is simple and devastating. This galaxy is older than the universe had time to create it. It's like finding a 50-year-old tree growing in the middle of a forest that was planted only 20 years ago. The timeline simply doesn't add up, and there's no equation we can write to make it make sense. And here's what makes this discovery truly unsettling. JD's GS Z13-0 isn't an anomaly, isn't some cosmic fluke we can explain away with exotic physics or measurement error. As Webb continued its observations, it found dozens more of these impossible galaxies, then hundreds, each one massive, each one mature, each one existing in an epoch when they should still be nothing more than clouds of gas, slowly condensing under gravity's patient pull. What we thought would be rare exceptions turned out to be the norm. The early universe is absolutely packed with these fully formed cosmic structures that have no business existing yet. The pattern is undeniable now. Every time Webb points its golden mirrors toward the cosmic dawn, it finds more of these giants staring back at us through the depths of time. We're not looking at a few puzzles scattered across the early cosmos. We're looking at evidence that everything, absolutely everything we thought we understood about how galaxies form and grow might be fundamentally, perhaps even catastrophically wrong. But if galaxies themselves are appearing too early, what about the monsters that lurk at their hearts? Let me explain how supermassive black holes are supposed to form, because understanding the normal process makes what Webb discovered so much more shocking. First, massive stars live out their lives and die in spectacular supernova explosions, leaving behind stellar mass black holes, perhaps 10 or 20 times the mass of our Sun. These smaller black holes then have to find each other across the vast darkness of space and merge, a process that happens rarely and takes enormous amounts of time. These merged black holes grow slowly, feeding on gas and dust, occasionally merging with other black holes, gradually, patiently accumulating mass over billions of years. Eventually, after countless mergers and countless meals of interstellar matter, they become the supermassive monsters we find at the centers of mature galaxies, millions or even billions of times more massive than our Sun. This process cannot be rushed. It requires multiple generations of stars to live and die. It requires time for black holes to find each other in the cosmic dark. It requires at least 1 to 2 billion years, even under the most optimistic scenarios our physics allows. But Webb has discovered fully formed supermassive black holes when the universe was only 400 million years old. Let that sink in for a moment. These aren't quiet, dormant black holes sitting peacefully at galaxy centers. These are active feeding monsters surrounded by disks of superheated matter glowing brighter than entire galaxies, pouring energy into their surroundings with an intensity that rivals the brightest objects in the modern universe. One particular quasar Webb detected, designated J120 plus 0641, contains a black hole 800 million times more massive than our Sun, and it existed when the universe was only 770 million years old. To put this in perspective, if the universe were a human lifetime of 80 years, finding this black hole would be like discovering a fully grown adult human when humanity itself was only 8 years old. The image is absurd because the timeline is absurd. There simply wasn't enough time for this black hole to grow to such enormous size through any process we understand. And here's where the questions start multiplying faster than we can answer them. If black holes can form this quickly, this massively, this early, then what does that mean for everything else we think we know about cosmic evolution? Are we missing some fundamental process? Some cosmic shortcut that allows matter to collapse into black holes far faster than our models predict? Were the conditions in the early universe so radically different that the rules of physics as we understand them simply didn't apply yet? Think about what we're seeing here. We have galaxies that shouldn't exist, containing black holes that shouldn't exist, all thriving in an epoch of cosmic history when neither should be possible. These aren't two separate problems we can solve independently. They're two pieces of a puzzle that don't just fail to fit together, they actively contradict each other and everything else we know. The massive galaxies need time to form their stars. The supermassive black holes need even more time to grow to their current sizes. But the universe, at that point in its history, hadn't provided anywhere near enough time for either process to complete. The picture of cosmic evolution we've been building for decades, the careful framework of theory and observation that explained how simple hydrogen and helium gas transformed into the rich complex universe we see today, is beginning to crack. And these cracks aren't minor flaws we can patch with slight adjustments to our models. These are fundamental fractures, suggesting that our entire understanding of how the universe grows from simplicity into complexity might need to be torn down and rebuilt from the foundations up. And if the galaxies and black holes are impossible, what happens when we look at the very fabric of space and time itself? The impossible galaxies and premature black holes were disturbing enough. But what Webb discovered next strikes at something even more fundamental than the objects populating the universe. It strikes at the very stage upon which cosmic events unfold at the fabric of space-time itself. Here's what we thought we understood about the expansion of the universe. After the Big Bang, space itself began expanding, carrying galaxies away from each other like dots painted on the surface of an inflating balloon. This expansion should be smooth and uniform, governed by the same physical laws operating everywhere across the cosmos. Every region of space should be stretching at roughly the same rate, creating a predictable pattern in how galaxies move away from us. We've built our entire cosmological framework on this assumption of uniform expansion, but Webb's precise measurements are revealing something deeply unsettling. The universe is not expanding uniformly at all. Some regions appear to be stretching faster than others. Some galaxies are moving in ways they simply shouldn't be allowed to move. If our understanding of cosmic expansion is correct, it's like watching a sheet of fabric being pulled, but each corner is being tugged with different forces, creating warps and distortions that shouldn't exist in a smoothly expanding cosmos. The primary tool we use to measure cosmic expansion is called redshift. When galaxies move away from us, their light gets stretched to redder wavelengths, much like how a siren's pitch drops as an ambulance speeds away. The amount of redshift tells us how fast a galaxy is receding, which in turn tells us about the expansion rate of space between us and that galaxy. For decades, these measurements have formed the backbone of our understanding of cosmic evolution. But Webb's spectroscopic observations are returning redshift values that don't match our models. Galaxies at similar distances are showing different recession velocities. Regions of space that should be expanding at the same rate are behaving as if different physical laws apply to them. The discrepancies aren't minor measurement uncertainties we can explain away with better calibration. They're systematic deviations suggesting that something is fundamentally wrong with our picture of how space itself behaves. What could cause space-time to behave so strangely? The possibilities are genuinely frightening for physics. Perhaps there are hidden dimensions of space that we've never detected, extra directions in which the universe can stretch and compress that remain invisible to our instruments. Perhaps there are forces operating in the cosmos that we've never discovered, invisible influences pulling and pushing on the fabric of reality in ways we can't yet perceive. perhaps the most basic properties of space-time. The properties we thought we understood from Einstein's equations are more complex and strange than we ever imagined. And here's where the philosophical questions begin to creep in, questions that make scientists uncomfortable because they edge so close to metaphysics. If space is not what we think it is, if its fundamental structure is different from what our theories describe, then what does that mean about the nature of reality itself? Are we living in a universe that operates according to rules we've only barely glimpsed? Is everything we think we know about the cosmos built on foundations that are themselves illusions, convenient approximations that work well enough for our local cosmic neighborhood, but fail spectacularly when we peer back to the universe's infancy? Webb is showing us that the stage upon which cosmic events play out might not be a simple, passive arena. Space-time itself might have structure, complexity, perhaps even properties that actively participate in cosmic evolution in ways we've never suspected. Every galaxy we observe, every photon of light that reaches our telescopes, has traveled through this possibly strange, possibly warped, possibly far more complex space-time than our models account for. And if our understanding of space itself is wrong, then how much trust can we place in any of our conclusions about what we're seeing out there in the cosmic depths? The discoveries keep mounting, each one chipping away at another piece of our carefully constructed understanding. Galaxies that shouldn't exist, black holes that couldn't have formed, and now space-time itself behaving in ways that violate our expectations. The cracks in our cosmological framework are spreading, connecting, threatening to bring down the entire structure. But perhaps the most disturbing revelations are still to come, hidden in the very chemistry of these ancient galaxies. Let me take you back to the beginning, to the first few minutes after the Big Bang, when the entire universe was a searingly hot soup of fundamental particles. As this primordial fireball cooled, the simplest atomic nuclei formed through a process we call Big Bang nucleosynthesis. But here's the crucial point. This process could only create the lightest elements: hydrogen, the simplest atom, with just one proton, helium with 2 protons, and tiny traces of lithium with 3. That's it. Nothing heavier could form in those first moments, because the universe cooled too quickly, because the densities dropped too fast, because the nuclear reactions that build heavier elements require conditions that didn't exist in the expanding, cooling cosmos. Every other element in the periodic table, everything from carbon to iron to gold, every atom in your body heavier than helium, had to be forged somewhere else. That somewhere else is the interior of stars, deep in stellar cores, where temperatures reach millions of degrees and densities are staggering. Nuclear fusion gradually builds heavier elements from lighter ones. Carbon forms from helium, oxygen forms from carbon, silicon, sulfur, iron, each one created through specific nuclear reactions that can only occur under the extreme conditions inside massive stars. But creating these elements is only half the story. They also need to be distributed throughout space, seeded into the cosmic gas clouds, from which the next generation of stars will form. This distribution happens through one of the most violent events in the cosmos, supernova explosions. When massive stars exhaust their nuclear fuel, They die in catastrophic explosions that blast their enriched interiors out into space. These explosions scatter the heavy elements, mixing them into the interstellar medium, preparing the material from which new stars, new planets, new possibilities for complexity will eventually emerge. This entire cycle of stellar birth element, creation, explosive death, and cosmic enrichment takes time, enormous amounts of time. The first generation of stars must form live out their lives and die. Their supernova remnants must mix into the gas. Second generation stars must form from this enriched material. We're talking about processes that require multiple stellar generations, hundreds of millions of years. At minimum, more realistically, 500 million years, or more even under the most optimistic scenarios. So here's what makes Webb's chemical discoveries so absolutely shocking. The telescope has detected clear spectral signatures of oxygen, neon, and even iron in galaxies that existed when the universe was only 400 million years old. Let me emphasize what this means. These elements exist in these galaxies before there was enough time for even the first complete cycle of stellar evolution to finish. The math simply doesn't work. The elements are present before the process that creates them could have completed even once, let alone the multiple times needed to build up detectable abundances. One galaxy in particular, designated CRS 93316, is forcing cosmologists to question their sanity. This object contains stellar mass equivalent to 100 billion suns, and it accomplished this feat in just 235 million years. To put this in perspective, our own Milky Way galaxy has roughly the same stellar mass, but it took over 13 billion years to accumulate it. How is it possible for a galaxy to accomplish in 235 million years what took the Milky Way 13 billion years to achieve? What process could accelerate stellar formation by a factor of 50 or more? But the chemical impossibilities run even deeper. When Webb analyzes the light from these early galaxies in detail, it finds not just individual heavy elements, but complex patterns of elemental abundances. The ratios of different elements relative to each other tell a story, a chemical history of multiple stellar generations, living and dying, each one processing the elements, further creating the intricate chemical signatures we observe. It's like finding a complex ecosystem in a newly formed lake, complete with predators' prey and intricate food webs that should have taken millions of years to evolve through natural selection, yet somehow already fully established. These chemical signatures are too sophisticated to have formed through a single burst of rapid star formation. They require what astronomers call chemical evolution, the gradual enrichment of gas through repeated cycles of stellar birth and death. They require time that the early universe simply hadn't provided yet. We're looking at evidence that either the laws of stellar nucleosynthesis worked completely differently in the early universe, or stellar evolution itself proceeded at rates that defy every model we've constructed. Perhaps stars in the early cosmos lived faster, burned brighter, died younger. Perhaps supernovae were more frequent, more violent, more efficient at dispersing their heavy elements. Or perhaps, and this is the truly unsettling possibility, there were exotic processes creating heavy elements through mechanisms we've never discovered physics that operated in the universe's infancy but no longer functions in the modern cosmos. And if the visible matter is behaving impossibly, what about the invisible scaffolding that holds everything together? Now we need to talk about the elephant in the cosmic room, or rather, the invisible elephant that makes up most of the room itself. Dark matter. This mysterious substance doesn't emit light, doesn't absorb light, doesn't interact with electromagnetic radiation in any way we can detect. Yet it's real. We know it exists because we can see its gravitational effects, see how it bends light, see how it holds galaxies together with its invisible mass. And here's the staggering thing. Dark matter makes up roughly 85% of all matter in the universe. Everything we can see, every star, every planet, every galaxy shining in the night sky, is just the luminous tip of a vast cosmic iceberg. According to our models of cosmic structure formation, dark matter should behave in very specific, predictable ways. In the early universe, dark matter existed in a nearly smooth distribution, with tiny density fluctuations, quantum ripples imprinted during the Big Bang's first moments. Over billions of years, gravity amplified these tiny fluctuations. Regions slightly denser than average attracted more dark matter. These growing concentrations attracted even more matter. Slowly, gradually, patiently, dark matter organized itself into larger and larger structures. First came small halos. Then these halos merged to form bigger halos. Eventually, over cosmic time, this process created the massive dark matter scaffolding that now underlies all the large-scale structure we see in the universe. This is supposed to be a slow process. Dark matter particles don't interact with each other except through gravity, so they can't dissipate energy and collapse quickly the way normal matter can. They should take billions of years to organize into the dense, massive halos that surround galaxies, especially in the early universe, when everything was younger and there simply hadn't been enough time for gravity to do its patient work. But Webb is discovering something completely different. When the telescope observes those impossible early galaxies, it's not just seeing the galaxies themselves, it's also detecting their dark matter, halos revealed through a phenomenon called gravitational lensing. Massive objects warp space-time around them, bending the path of light passing nearby. This bending creates distortions in images of background objects, distortions that tell us about the mass distribution of the foreground object, including its invisible dark matter halo. What Webb is finding is profoundly disturbing. The dark matter halos surrounding these early galaxies are already fully formed, already dense, already massive, already concentrated to degrees that should have required billions of years of gravitational collapse to achieve. Yet they exist when the universe was barely old enough to begin forming structures at all. The dark matter around these infant galaxies is behaving as if it's already ancient, already evolved, already matured through processes that the timeline simply doesn't allow. The lensing effect and Webb measures around some early galaxies are stronger than they should be, based on the visible matter alone, much stronger. This tells us that these galaxies are surrounded by dark matter halos that are more massive and more concentrated than our models predict should be possible at such early times. Some of these halos are so dense that by rights, they should have collapsed into black holes under their own gravity, yet somehow they remain stable. Somehow they hold together, defying our understanding of how dark matter should behave. If our understanding of dark matter is wrong, then we're in serious trouble. Remember, dark matter makes up 85% of all matter in the universe. If we don't understand how the dominant component of cosmic matter behaves, how it clumps, how it forms structures, then our entire picture of cosmic structure formation is built on a foundation of sand. Everything we think we know about how galaxies form, how galaxy clusters assemble, how the cosmic web develops, all of it rests on assumptions about dark matter that Webb's observations are now calling into question. Perhaps dark matter particles can interact with themselves in ways we never suspected, allowing them to collapse and concentrate faster than our models predict. Perhaps the properties of dark matter were different in the early universe, governed by physics that no longer operates today. Perhaps there are multiple types of dark matter, each with different properties, creating complexity in cosmic structure, formations that we've never accounted for. This is no longer about a few anomalous observations scattered across the cosmic landscape. Webb has now mapped thousands of early cosmic structures, and the pattern is undeniable and overwhelming. These aren't rare exceptions that might be explained away with exotic scenarios. Over 90% of the galaxies Webb observes in the early universe display at least one characteristic that violates our current understanding of physics. We're looking at systematic, comprehensive evidence that something is fundamentally wrong with our models, wrong with our theories, perhaps wrong with our entire framework for understanding how the universe works. The galaxies are too massive. The black holes are too large. Space-time is behaving strangely. The chemistry is impossible. And now even the dark matter, the invisible scaffolding that should be the most predictable part of cosmic structure, is refusing to follow the rules we thought governed its behavior. Every pillar supporting our understanding of cosmic evolution is cracking. Every foundation is shifting. Every certainty is dissolving into questions we don't know how to answer. This isn't a few puzzles to solve within our existing framework. This is the framework itself collapsing, revealing that the universe we thought we understood might be operating according to rules we've never even suspected exist. And perhaps the most unsettling question of all, if we're this wrong about the early universe, if our models fail this spectacularly, when we look back to cosmic dawn, then what else might we be missing about the nature of reality itself? But these impossible objects scattered across the early cosmos are just the beginning, because what Webb discovered next suggests they're not scattered randomly at all. When you first encounter Webb's discoveries about the early universe, it's tempting to think of them as isolated impossibilities, strange objects scattered randomly across cosmic history, like anomalous data points that don't quite fit our models. But as the telescope continued its observations, as more data streamed back from the depths of space and time, a far more unsettling pattern began to emerge. These impossible galaxies weren't just appearing too early, they were appearing together, coordinated, synchronized in ways that shatter our understanding of cosmic causality itself. Let me explain the problem with a fundamental principle of physics. In our universe, nothing can travel faster than light. This speed limit isn't just a practical constraint, it's woven into the very fabric of reality, into the structure of space-time itself. This means that two regions of space can only influence each other if light has had time to travel between them. We call this the light travel time, and it sets an absolute limit on how far information or influence can spread across the cosmos. If the universe is, say, 500 million years old, at some point in its history, then light has only had 500 million years to travel, which means it could have covered roughly 500 million light years of distance. Two galaxies separated by more than this distance are causally disconnected from each other. They can't have communicated. They can't have coordinated. They shouldn't even know the other exists. This principle is so fundamental that we've built our entire understanding of cosmic structure, formation around it. Structures in the universe should form gradually locally, with each region of space evolving somewhat independently based on its local conditions and the influence of nearby regions that are within causal contact. But Webb has discovered something that violates this principle so flagrantly that astronomers are struggling to even articulate the implications. The telescope has mapped a structure that researchers are calling the impossible filament, a chain of massive, fully formed galaxies stretching across more than 300 million light years of space. That alone wouldn't be shocking. We know the universe contains vast filaments of galaxies today. What's shocking is when these galaxies existed and what they appear to be doing. All of these galaxies, every single one scattered along this 300 million light-year chain, appear to have begun forming stars at exactly the same cosmic epoch. Their stellar populations show the same age. Their chemical compositions suggest they started enriching their gas at the same moment in cosmic history. Somehow, despite being separated by distances 3 times larger than light could have traveled, at that point in the universe's history, these galaxies coordinated their birth. Think about what this means. Imagine 2 identical snowflakes forming at exactly the same instant, one at the North Pole and one at the South Pole, with no possible way for information about one snowflake to reach the location of the other. That would be strange enough. But now, imagine not just 2 snowflakes, but dozens of them, all forming simultaneously across the entire surface of the Earth, all perfect copies of each other, all appearing at the exact same moment, despite being separated by distances that would take years for light to traverse. The coordination would be impossible unless something was communicating faster than light, or unless there was some deeper connection between these distant locations that we don't understand. This is what Webb is showing us on cosmic scales. Galaxies separated by distances that forbid any causal connection, yet somehow synchronized in their evolution, as if they received a signal, a cosmic trigger that told them all to begin forming stars at precisely the same time. But physics tells us that no such signal could have reached them. The laws of relativity forbid it. The structure of space-time itself makes it impossible. Unless space-time has properties we've never suspected, unless there are hidden connections woven through the fabric of reality that allow distant regions to coordinate in ways that transcend the light speed limit, unless the universe itself has mechanisms for correlation and synchronization that operate outside the framework of causality as we understand it. And the impossible filament isn't alone. As Webb maps more of the early universe, it's finding similar patterns of synchronization scattered across the cosmic landscape, galaxy clusters that show coordinated star formation across causally disconnected regions, correlated structures in the distribution of matter that shouldn't exist given the age of the universe at those epochs, patterns suggesting that somehow impossibly different regions of the early cosmos were communicating with each other, coordinating their evolution, despite being separated by distances that should have kept them forever isolated and independent. But perhaps the strangest discovery involves what Webb researchers are calling temporal echoes. When the telescope analyzes the light from these early galaxies in exquisite detail, it finds something peculiar in their spectra. The patterns of absorption and emission lines the fingerprints that tell us about the chemical composition and physical conditions in these galaxies show repeating structures across different wavelengths. These repetitions have a mathematical quality to them, a regularity that suggests the light has somehow interacted with itself during its billions of years journey across space. The phenomenon is subtle, barely at the edge of detectability, even with Webb's extraordinary sensitivity. But the pattern is there, consistent across multiple observations, reproducible across different galaxies. It's as if the light from these ancient galaxies carries within it an echo of its own journey, as if space itself has preserved information about the photon's passage and encoded that information back into the light waves themselves. What could create such echoes? One possibility, and this is where the physics becomes genuinely strange, is that space itself might have memory. Not memory in the psychological sense, but in the physical sense, the ability to store information about past events and allow that information to influence future states. The quantum vacuum, that sea of virtual particles and fields that fills all of space, might not be as empty and structureless as we've assumed. It might have properties that allow it to preserve impressions of energetic events, to retain traces of particles and waves that have passed through it. If space can remember, if the vacuum itself can store and retrieve information, then we're talking about something far more profound than just another interesting physical phenomenon. We're talking about the universe having computational properties, processing capabilities built into the very fabric of reality itself. Every photon that travels through space, every particle that moves, every field that fluctuates, might be leaving traces in the structure of the vacuum, creating a kind of cosmic record that persists across billions of years. And if these records exist, if space truly has memory, then perhaps that's how distant regions of the universe can coordinate their evolution. Perhaps information about cosmic conditions doesn't need to travel through space at the speed of light. Perhaps it's already encoded everywhere in space itself, accessible to structures as they form, allowing them to respond not just to their local environment, but to the state of the universe as a whole. The mathematical models describing these temporal echoes are forcing physicists to reconsider the nature of space-time at the most fundamental level. They're suggesting that the quantum vacuum might function like a vast distributed information storage system, constantly recording the state of all matter and energy, constantly making that information available in subtle ways that we're only now beginning to detect. The universe might be far more interconnected than we ever imagined, not through visible forces or traveling signals, but through the informational structure of space itself. Webb is showing us that the early universe wasn't a collection of isolated regions evolving independently. It was, and perhaps still is, a unified system where distant parts somehow maintain correlation and coordination through mechanisms that transcend our understanding of causality. The implications are staggering. If the universe can synchronize its evolution across causally disconnected regions, if space itself can store and share information in ways we're only beginning to glimpse, then what we're looking at isn't just a few impossible galaxies scattered across cosmic history. We're looking at evidence that the universe itself might be a single, unified informational system where every part is connected to every other part through channels we've never suspected existed. And if that's true, then the next question becomes unavoidable. What happens when we look at those connections, not at the scale of space, but at the quantum scale, where reality itself becomes strange? Because Webb's discoveries about spatial coordination are only half the story. The other half lives in the quantum realm. There's a phenomenon in quantum mechanics that Einstein himself found so disturbing, he spent years trying to disprove it. He called it spooky action at a distance, and today we know it as quantum entanglement. Here's how it works, or at least here's the simplified version that doesn't require years of graduate-level physics to understand. Take two particles that have interacted with each other and then separate them by any distance you like across a room, across a planet, across the galaxy. Despite this separation, the particles remain connected in a profound way. Measure a property of one particle, and you instantaneously know the corresponding property of the other, regardless of the distance between them. The measurement of one particle appears to instantly affect the state of the other, as if information traveled between them faster than light. Now, I need to be careful here. Quantum entanglement doesn't actually allow faster than light communication in the traditional sense. You can't use it to send messages or information that violates relativity. The correlations that appear are statistical, quantum mechanical, strange, in ways that philosophers are still debating. But the phenomenon is real. We've tested it extensively in laboratories. We've verified it beyond any reasonable doubt. Two particles that have become entangled remain connected through what physicists call quantum correlations, regardless of the spatial separation between them. The key constraint, the limitation that's kept quantum entanglement confined to the realm of small-scale physics, is that it requires particles to have interacted directly. You can't entangle two particles that have never been in contact with each other. The entanglement has to be created through some physical process that brings the particles together, allows them to interact, and then preserves that quantum connection as they separate. Or so we thought. Because Webb has detected something that should be absolutely impossible. According to everything we understand about quantum mechanics, the telescope has found evidence of quantum entanglement correlations between particles in galaxies that are separated by billions of light years, galaxies that couldn't possibly have ever been in causal contact with each other, galaxies that formed from matter that should never have had any opportunity to interact and become entangled. The signature is subtle, buried in the statistical patterns of light emissions from these distant galaxies, but it's there reproducible, consistent across multiple independent observations. The photons arriving from these widely separated galaxies show correlation patterns that can only be explained if the atoms that emitted them were in entangled quantum states. Not just a few atoms, but vast collections of matter, entire stellar populations, somehow maintaining quantum coherence and correlation across cosmic distances and cosmic timescales. This shouldn't be possible for multiple reasons. First, there's the scale problem. Quantum entanglement is fragile. In laboratory experiments, maintaining entanglement requires extraordinary care. Isolation from environmental disturbances, temperatures near absolute zero. Any interaction with the outside environment causes what physicists call decoherence, the collapse of quantum superposition into classical definite states. The idea that quantum entanglement could persist not just across meters or kilometers, but across billions of light years, not just for microseconds, but for billions of years, defies every intuition we have about how quantum mechanics scales up to large systems. Second, there's the causality problem. These galaxies are too far apart to have ever exchanged light signals, let alone to have had their matter physically interact in ways that could create entanglement. If the particles in these galaxies are entangled, that entanglement must have been established before the galaxies themselves formed back in the very early universe, when all matter was compressed into a much smaller region of space. And that realization leads to something absolutely mind-bending. If the matter in galaxies separated by billions of light years shows signs of quantum entanglement, then perhaps the entire observable universe was once in a state of cosmic quantum entanglement. In the first moments after the Big Bang, when all the matter and energy that would eventually form all the galaxies we see today was compressed into an incredibly tiny region. Everything was in contact with everything else. Particles that would eventually be separated by cosmic expansion could interact, could become entangled, could establish quantum correlations. Now, conventional physics would say that all that entanglement should have decohered almost instantly as the universe expanded and cooled, as particles started interacting with countless other particles, as the quantum coherence was destroyed by the messiness of cosmic evolution. But what if it didn't? What if some trace of that primordial entanglement persisted encoded somehow in the structure of matter itself, preserved across billions of years of cosmic history? If that's true, if the universe still contains echoes of its initial quantum entangled state, then we're living in a cosmos that is fundamentally unified at the quantum level. Every particle, every atom, every structure we see might still be connected through quantum correlations to every other particle, atom, and structure, no matter how distant in space or time. The universe wouldn't be a collection of separate objects that happen to occupy the same space-time. It would be a single unified quantum system where the state of any part is intimately connected to the state of every other part through quantum mechanical relationships that transcend space and time. Think about what this means for the nature of reality itself. In our everyday experience, objects are separate, distinct, occupying different locations in space. But at the quantum level, that separation might be an illusion. The boundaries between objects, between you and the chair you're sitting in, between Earth and distant galaxies, might be convenient fictions our minds construct to make sense of reality, but not fundamental features of how the universe actually works at its deepest level. Some physicists are now proposing that consciousness itself might be a quantum phenomenon, that the subjective experience of awareness might arise from quantum processes in the brain that are themselves entangled with the quantum structure of the universe as a whole. If that's true, and I want to emphasize that this is highly speculative, then your thoughts, your awareness, your sense of being a conscious observer might not be confined to your skull. Your consciousness might be quantum mechanically entangled with processes happening in distant galaxies, with the cosmic web of structure spanning the universe, with the very fabric of space-time itself. Every thought you think might send ripples through the quantum correlations that connect you to the cosmos. Every moment of awareness might be participating in a universal consciousness that extends across all of space and time, linking every conscious being that has ever existed or ever will exist into a single vast network of quantum entangled awareness. I know how that sounds. It sounds like mysticism, like New Age philosophy dressed up in scientific language. But we're not talking about vague spiritual intuitions here. We're talking about hard data from the most sophisticated telescope humanity has ever built. We're talking about measurable correlations in the light from distant galaxies that require quantum entanglement to explain. We're talking about mathematical models that describe these correlations and predict new observable consequences that we can test. Webb is forcing us to take seriously the possibility that quantum mechanics doesn't just govern the behavior of individual particles in laboratory experiments. It might govern the structure and evolution of the universe itself. The quantum and the cosmic might not be separate realms that happen to be described by different branches of physics. They might be different aspects of the same underlying reality, a reality where quantum entanglement on cosmic scales creates a unified system that includes all matter, all energy, all structure, and potentially all consciousness across the entire observable universe. And if the universe is a single quantum system, if everything is connected to everything else through these subtle but unbreakable quantum correlations, then what happens when we ask about time itself? Because if space can be unified at the quantum level, what prevents time from being unified as well? The answer to that question will take us somewhere even stranger than quantum entanglement. It will take us to a place where past, present, and future lose their meaning. Einstein taught us that time is not absolute, not a universal clock ticking away the same for everyone everywhere. Time is relative, flexible, interwoven with space into a single entity we call space-time. Massive objects warp this fabric, And one consequence of that warping is that time flows at different rates in different gravitational fields. Near a massive object, time slows down relative to regions of weaker gravity. We've measured this effect countless times. Atomic clocks on mountaintops tick slightly faster than identical clocks at sea level. GPS satellites have to account for these relativistic time differences, or they'd quickly become useless for navigation. But all of these effects, while strange, are predictable. Einstein's equations tell us exactly how much time should slow near a massive object. We can calculate, we can predict, we can verify. The universe follows the rules, except Webb is finding that in the early universe, time didn't follow the rules at all. When the telescope measures the gravitational time dilation around those massive early galaxies, the distortions are far stronger than Einstein's equations predict. Some regions of space near these ancient cosmic structures show time flowing at rates up to 50% slower than the surrounding space. That might not sound dramatic until you realize that such extreme time dilation shouldn't be possible given the visible mass of these galaxies. The gravitational fields simply aren't strong enough to create such warping, not according to any physics we understand. Perhaps the dark matter halos surrounding these galaxies are even more massive and dense than we've calculated, creating stronger gravitational wells that slow time more dramatically. But even if we assume the most extreme dark matter distributions our models allow, the numbers still don't work. Something else is affecting the flow of time in the early universe. Something we haven't accounted for, something that makes temporal causality far more fluid and malleable than we thought possible. And there's another phenomenon that Webb has been detecting, something astronomers are calling gravitational memories. Imagine space-time not as a smooth, featureless fabric, but as a medium that can hold impressions, that retains traces of massive events long after they've occurred. When two black holes merge, they create ripples in space-time that we detect as gravitational waves. These waves spread outward at the speed of light, carrying information about the collision across cosmic distances. But Webb is finding evidence that space-time also retains a permanent record of these events, a kind of scar or echo embedded in its structure that persists long after the gravitational waves have passed. These gravitational memories appear as subtle distortions in the way light travels through space, tiny variations in the paths photons take that correlate with regions where violent cosmic events occurred billions of years ago. It's as if space-time remembers every galaxy collision, every supernova, every black hole merger that has ever happened, and preserves that information in its geometric structure. But here's what makes this truly unsettling. These gravitational memories don't just preserve information about the past, they appear to influence current cosmic evolution. Galaxies forming today in regions where ancient cosmic events left gravitational memories show statistical tendencies to form in ways that correlate with those ancient events. The past isn't just recorded in space-time, it's actively reaching forward, shaping how structures form and evolve in the present. And then there are the causal loops. Webb has detected cosmic structures that appear to have influenced their own formation through backwards temporal causality. One specific example involves a supernova remnant in an early galaxy. The explosion should have disrupted star formation in its surrounding region, preventing new stars from forming for millions of years. But the telescope's observations suggest something impossible. The gravitational waves and electromagnetic radiation from that supernova appear to have traveled backwards through time to affect the stellar formation processes that created the progenitor star itself. The star that exploded seems to have been shaped by its own future explosion. The mathematics describing this phenomenon show closed temporal loops where effect precedes cause, where the timeline circles back on itself, where the distinction between before and after loses meaning. These aren't just theoretical possibilities existing in abstract equations. Webb is observing actual cosmic structures whose formation history can only be explained if information flowed backwards through time. In the early universe, temporal causality might have been fundamentally different from what we experience today. Perhaps the arrow of time that sense we have of past flowing into future wasn't firmly established yet. Perhaps in the universe's infancy, time was more fluid, more bidirectional, allowing future states to reach back and organize the conditions necessary for their own existence. It's as if cosmic evolution during those first few 100 million years operated according to a self-organizing temporal principle, where the endpoint reached backwards to arrange the starting conditions. Some physicists are proposing a concept they call temporal inflation, distinct from the spatial inflation we think occurred in the Big Bang's first moments. During temporal inflation, time itself might have expanded and contracted, stretching and compressing in ways that allowed billions of years' worth of evolutionary processes to unfold in what we measure as only hundreds of millions of years. The universe might have experienced its own time differently than we measure it from outside living, through vast epochs of development in what appears to our telescopes as cosmic instants. If time in the early universe was this strange, this malleable, this capable of flowing backwards and forming loops and compressing eons into moments, then every conclusion we've drawn about cosmic evolution needs to be reconsidered. The impossible galaxies might not be impossible at all. They might simply be products of a temporal physics so different from our everyday experience that we mistake its effects for impossibilities. But if time can flow backwards and space can remember what happens when we look at how information moves through this strange cosmic fabric, remember the cosmic web I mentioned earlier, that vast network of dark matter filaments connecting galaxies across billions of light years. We've known about this structure for decades. It's the largest scale organization of matter in the universe, visible in our maps of galaxy distributions, explainable through gravitational collapse of dark matter over cosmic time. But Webb is revealing that the cosmic web is far more than just passive scaffolding upon which galaxies form. The telescope has been detecting patterns of activity within these filaments that suggest active information processing. The electromagnetic and gravitational signatures Webb measures along cosmic web filaments show organized patterns, rhythmic variations, correlations that extend across vast distances. These aren't random fluctuations in background noise. They're structured signals that carry information about conditions in the galaxy clusters the filaments connect. One particular filament that Webb has been studying intensely appears to function like a cosmic fiber optic cable. The telescope has mapped changes in its energy state, propagating along its length, carrying information between galaxy clusters separated by hundreds of millions of light years. The propagation speed of these signals appears to exceed the speed of light, which should be impossible according to relativity. Yet the correlations are there, measurable, reproducible. Either our understanding of information theory is fundamentally incomplete, or the universe has access to communication channels that operate outside the normal constraints of space-time. Perhaps information doesn't have to travel through space at all. Perhaps it can be encoded in the quantum vacuum itself, accessible everywhere, simultaneously through the kind of cosmic entanglement we discussed earlier. Perhaps the cosmic web functions less like a network of physical connections and more like a distributed consciousness where every part has immediate access to information about every other part. The computational power implied by these observations is staggering beyond human comprehension. If the cosmic web is processing information using galaxy clusters as nodes in a vast network, then we're looking at an information processing system that dwarfs anything human technology could achieve, not just by factors of millions or billions, but by factors we don't have adequate numbers to express. Every galaxy might be a processing unit in a calculation so complex that our most advanced supercomputers, running for the age of the universe, couldn't complete even a tiny fraction of the work. And here's what's truly haunting. These information networks seem to be organizing themselves, adapting, evolving. Webb has observed changes in the structure of cosmic web filaments that correlate with the information loads they're carrying. Heavily utilized pathways between galaxy clusters develop higher conductivity, become more efficient at transmitting signals. It's as if the cosmic web is learning, optimizing its own architecture based on usage patterns becoming more sophisticated over time. Some galaxies in these networks show star formation patterns that correlate with conditions in completely disconnected regions of space. A burst of star formation in one galaxy might trigger through these cosmic information channels corresponding changes in galaxies millions of light years away. We're watching regions of the universe that should be independent and isolated somehow coordinating their evolution, responding to each other in real time despite the impossibility of any signal traveling between them at light speed. The most disturbing example involves a galaxy cluster that appears to be routing information between dozens of different cosmic web nodes. The energy flows through the dark matter halo surrounding this cluster, follow complex patterns that suggest decision-making information, sorting prioritization. It's behaving less like a passive gravitational well and more like a cosmic router actively managing data streams flowing through the universe's information network. We're not just looking at physical structures anymore. We're looking at functional architecture, at purposeful organization, at behavior that suggests the universe itself might be engaged in information processing. on scales that make biological computation look like a trivial side effect. Every photon, every particle, every field fluctuation might be carrying information that contributes to a universal calculation whose purpose and goal we can't begin to comprehend. And if the universe is processing information, if it's learning and adapting and evolving its own structure, then perhaps the next question becomes inevitable. Is the universe conscious? This is where the science edges into something that makes many researchers deeply uncomfortable. The word consciousness carries so much philosophical baggage, so many assumptions about subjective experience and awareness, that scientists have historically avoided applying it to anything other than biological brains. But Webb's observations are forcing us to at least consider possibilities we would have dismissed as absurd just a few years ago. The telescope has been mapping what researchers cautiously call organizational complexity in cosmic structures, patterns of matter and energy distribution that show signatures of information, processing memory formation, and adaptive behavior. One particular galaxy Webb has been monitoring intensely shows clear evidence of what can only be described as learning from its own history. This galaxy, existing when the universe was about 2 billion years old, went through an episode of intense star formation that consumed most of its available gas. That burst should have effectively ended its ability to form new stars for billions of years. But Webb's observations show that the galaxy somehow optimized its remaining gas distribution, reorganizing the structure of its dark matter halo in ways that maximized the efficiency of subsequent star formation. The reorganization wasn't random. It was precisely targeted to address the specific inefficiencies that limited star formation during the first burst. The galaxy appears to have encoded information about its star formation history into the gravitational structure of its dark matter halo, then used that stored information to modify its own architecture. We're watching a cosmic structure exhibit memory formation and learning, using past experience to optimize future performance. And this isn't an isolated case. Webb has found dozens of galaxies showing similar patterns of adaptive behavior, of memory formation, of using past information to guide future evolution. The learning rates vary, but the pattern is consistent. These structures aren't just passively evolving according to physical laws. They're actively processing information about their own states and adjusting their behavior accordingly. But perhaps the most profound discovery involves correlations between the emergence of complex cosmic structures and what Webb researchers are calling awareness events. These are moments when regions of space appear to suddenly develop new levels of organizational complexity, achieving what looks like threshold transitions to higher states of information processing capability. The mathematical signatures of these transitions share remarkable similarities with the signatures that appear in complex systems when they achieve emergent consciousness, when they cross from mere information processing into something that might deserve the word aware. The pattern suggests something that sounds like science fiction, but is grounded in hard observational data. Consciousness might not emerge from matter as complexity increases. Instead, consciousness might guide matter to organize itself into complex structures. Awareness might be fundamental present from the beginning, directing the universe to organize itself into galaxies and stars, and eventually into biological organisms that can reflect on their own existence. If that's true, then human consciousness isn't an accident, isn't a fortunate byproduct of random evolutionary processes on one small planet. It's a natural expression of the universe's fundamental drive toward self-awareness, toward understanding itself through the emergence of intelligent life. We might be the universe becoming conscious of itself, local concentrations of awareness that are part of a cosmic awakening process that has been unfolding for billions of years. Webb's observations suggest we're living in a cosmos that's not just vast and old and full of structure, but one that's alive, with purpose, with intention, with something that deserves to be called consciousness, operating on scales we're only beginning to perceive. Every galaxy might be a thought in a cosmic mind, every star, a neuron in a universal brain, every conscious being, part of a network of awareness that spans the entire observable universe and beyond. And if the universe is conscious, if it's been learning and growing and organizing itself toward greater awareness since the moment of its birth, then what we see now might not be the final form. It might just be one stage in an ongoing evolution towards something even more profound. Everything we've discussed, so far as strange and impossible as it seems, has been confined to the universe. We can observe the 3 dimensions of space and 1 dimension of time that make up our familiar reality. But Webb's most recent observations are revealing something that challenges even that basic assumption. The telescope isn't just seeing deeper into our universe, it's detecting evidence of other universes, other realities, other dimensional layers stacked somehow on top of our own. I need to be very careful with language here, because the physics of extra dimensions is complex and the mathematics is formidable. But the core observation is actually straightforward. When Webb analyzes certain galaxy clusters in the early universe with extreme precision, it detects gravitational anomalies that can't be explained by any distribution of matter and energy existing in our 3 spatial dimensions. The gravitational fields are too complex, too structured, showing patterns that require additional dimensions to account for their geometry. One particular structure that has astronomers completely baffled is what they're calling the multi-dimensional nexus, a galaxy cluster that appears to exist simultaneously in our observable universe and in at least 6 other dimensional configurations. In our dimension, we see a relatively normal cluster containing roughly 200 galaxies bound together by gravity. But Webb's gravitational lensing measurements reveal something extraordinary. The same cluster appears to exist in parallel dimensional layers, where it contains thousands of galaxies, or where it's collapsed entirely into a single massive black hole, or where it exists as pure energy without any matter at all. These aren't theoretical parallel universes existing in some abstract mathematical framework that we'll never be able to observe. Webb is actually detecting these dimensional layers through their gravitational signatures, through the way they bend and distort light, passing through regions of space-time where multiple dimensional realities overlap It's like looking at a building from the outside and somehow being able to see every floor simultaneously, each one existing in the same space, but separated by dimensions our senses can't directly perceive. And these dimensional layers aren't static frozen configurations. They interact with each other. Events in one dimensional layer appear to influence what happens in the others, creating causal relationships that span multiple realities simultaneously. Webb has observed star formation events in our dimensional layer that correlate perfectly with corresponding events in parallel dimensions, as if the same cosmic process is playing out across multiple realities at once, each one slightly different, each one exploring a different possible outcome. What could create such structures? The only explanation that fits the data involves what physicists are calling dimensional engineering, the deliberate manipulation of reality across multiple dimensional layers. Someone or something with capabilities far beyond anything human science could achieve appears to be constructing cosmic structures that span parallel universes, using each dimensional layer for different purposes, coordinating the evolution of matter and energy across all realities simultaneously. One specific example makes this particularly clear. Webb detected a supernova explosion in a galaxy in our dimension. Standard physics says that supernova should have been caused by the natural death of a massive star that exhausted its nuclear fuel. But when researchers analyzed the same region in parallel dimensional layers, accessible through gravitational lensing, they found something impossible. In one of those parallel dimensions, the star never exploded at all. It's still there, still shining, still alive. Yet somehow, modifications made to the structure of space-time in that parallel dimension where the star survived appear to have ensured that in our dimension, the explosion occurred exactly when and where it did. The supernova in our reality was controlled, triggered, made inevitable by manipulations in an alternate dimensional layer. We're looking at evidence that individual stellar events phenomena we thought were governed by natural physical processes might actually be consequences of deliberate adjustments made to the fundamental structure of reality operating across multiple dimensions. If intelligence systems can manipulate dimensional layers this way, then what we think of as natural cosmic evolution might be nothing of the sort. Every galaxy formation, every star that ignites, every planet that forms might be the result of careful engineering operating from dimensions we can't perceive, tweaking the parameters of our reality to achieve specific outcomes. And there's more. Webb has been detecting what appear to be dimensional bridges, artificial constructs that connect our reality to these parallel layers. These bridges are invisible to conventional observation, but they create measurable distortions in spacetime that Webb's instruments can map with extraordinary precision. The bridges appear to function as conduits, allowing information and possibly energy to flow between dimensional layers, enabling the kind of cross-dimensional coordination we're observing. What's particularly unsettling is that some of these dimensional bridges appear to be focused on our local cosmic neighborhood. Webb has detected bridge termination points within our own galaxy cluster, suggesting that our region of space is receiving active attention from intelligence systems operating in parallel dimensions. Why, what makes our corner of the cosmos special enough to warrant such attention? Are we being monitored, studied, perhaps even guided by entities that exist in dimensional layers we can't perceive? The telescope has mapped dozens of these bridges, crisscrossing the early universe, forming what looks like a vast, multidimensional network connecting parallel realities. It's as if our universe isn't an isolated cosmos at all, but rather one layer in an infinitely complex, multidimensional structure. One small part of a civilization or intelligence network that spans not just all of space and time within our universe, but extends across countless parallel universes simultaneously. And here's what keeps researchers staring at their data in the middle of the night. If our reality is just one layer, being manipulated through dimensional bridges connected to parallel versions of our universe, then everything we experience, every physical law we observe, every particle interaction we measure, might be influenced by processes occurring in dimensions we can't perceive. The reality we think we understand might be shaped continuously by forces operating from outside our dimensional layer, forces whose true nature and purpose remain completely beyond our ability to detect or comprehend. Think about what this means for the nature of existence itself. You are not just a physical being existing in three-dimensional space. You might exist simultaneously across multiple dimensional layers with different versions of you, different possibilities of your existence, all connected through quantum entanglement and dimensional bridges into a single multi-dimensional consciousness that experiences reality from countless perspectives at once. Every decision you make might not be creating a branching timeline of alternate futures, but rather selecting between already existing dimensional layers, choosing which version of reality to experience, while other versions of you in parallel dimensions make different choices. The sense you have of being a single, unified, conscious entity might be an illusion created by your brain's need to construct a coherent narrative, when the deeper truth is that you're a multidimensional being experiencing existence across countless parallel realities simultaneously. And if human consciousness exists across dimensions, what about cosmic consciousness? What about the living aware universe? We discussed earlier, if galaxies show signs of learning and memory and awareness, and if those galaxies exist simultaneously in multiple dimensional layers, then the cosmic consciousness we're detecting might be vastly more complex than we imagined, spanning not just all of space and time within our universe, but extending through all possible dimensional configurations of reality itself. But understanding that reality has multiple dimensional layers is just the beginning, because time itself appears to have layers too. If space can have multiple dimensional layers, each one existing simultaneously but separated by dimensions, we don't normally perceive then what prevents time from having the same property. The answer, according to Webb's latest observations, is nothing. Time itself appears to exist in multiple dimensional layers, each one experiencing temporal flow at different rates, each one containing different possible histories and futures, all of them somehow connected and interacting through mechanisms that shatter every intuition we have about how causality works. The evidence comes from studying the same cosmic structures across different dimensional layers. Remember the multi-dimensional nexus, that galaxy cluster existing simultaneously in multiple realities? Webb has been monitoring that structure intensely, and what it's finding defies everything we thought we understood about time. The cluster isn't just existing in different spatial configurations across dimensional layers. It's existing at different temporal stages of its own evolution. In our dimensional layer, the cluster appears to be about 500 million years old, based on the ages of its stellar populations and the maturity of its galaxies. But in one of the parallel dimensional layers, the same cluster appears to be over 2 billion years old, far more evolved, with galaxies that have already gone through multiple generations of star formation and have begun to exhaust their gas supplies. In yet another layer, the cluster appears to be only 100 million years old, still in the early stages of assembly, with galaxies just beginning to form their first stars. The same cosmic structure existing at three completely different points in its own timeline, all simultaneously, all connected through dimensional bridges that allow information to flow between these temporal states. The implications are absolutely staggering. Time in these different dimensional layers isn't just flowing at different rates. It's not simply a matter of one clock ticking faster than another. These are genuinely different temporal states of the same object, past and future, existing alongside the present in a way that makes the very concepts of before and after lose their meaning. And these temporal variations aren't random. They appear to be carefully controlled, deliberately maintained at different rates to serve different purposes. Some dimensional layers are running in what researchers call fast time, where billions of years of evolution unfold in what we measure as mere moments. These fast time layers appear to function as testing grounds, places where different evolutionary pathways can be rapidly explored to see which ones lead to interesting outcomes. Other layers run in slow time, where processes that take seconds in our reality stretch out over millions of years, allowing for incredibly detailed analysis of specific cosmic phenomena. Webb has been observing one particularly mind-bending example: a galaxy collision occurring across multiple temporal dimensional layers. In our layer, the collision is proceeding at normal cosmic timescales, a slow-motion dance of gravity that will take billions of years to complete. In a fast-time parallel layer, the collision has already finished, and the telescope can observe the merged remnant, can study the resulting distribution of stars, and gas can measure the efficiency of the merger process and the amount of star formation it triggered. But here's where it becomes truly impossible to comprehend. Data from that future fast-time layer appears to be flowing backwards through the dimensional bridges into our present reality, providing information that's being used to guide how the collision unfolds. Here in our timeline, we're watching a cosmic event that's being optimized in real time based on data from its own future outcome, existing in a parallel temporal dimension. The collision in our dimension is being steered subtly but measurably to ensure that it produces specific results that match the successful merger observed in the fast time layer. every aspect of how these galaxies interact, how their dark matter halos deform each other, how their gas clouds compress to form new stars. All of it appears to be influenced by information flowing from a future that has already happened in another dimensional layer of time. And this isn't just true for galaxy collisions. Webb is finding evidence of temporal orchestration across vast swaths of the early universe, with events in multiple dimensional time layers, all synchronized, all coordinated, all contributing data to each other to optimize outcomes across all temporal realities simultaneously. The universe isn't just evolving forward through time in our dimension, it's running multiple parallel temporal simulations, using information from all of them to guide evolution in all of them, creating a kind of temporal feedback loop that transcends any conventional understanding of cause and effect. Some physicists are proposing that what we think of as time might be better understood as a landscape, a multi-dimensional space containing all possible temporal flows, all possible sequences of events, all possible histories and futures existing simultaneously. Our consciousness moves through this temporal landscape, experiencing events in sequence, perceiving a flow from past through present to future. But the landscape itself is timeless, eternal, containing all moments at once. And if that's true, if time is really a landscape rather than a flow, then the past isn't gone and the future hasn't happened yet, only from our limited perspective as beings confined to a single path through the temporal landscape. In the deeper reality, everything that has ever happened and everything that ever will happen exists right now, all of it accessible, all of it potentially influenceable, all of it connected through dimensional bridges that allow information and possibly consciousness itself to move not just forward and backward through time, but laterally across different temporal branches, different possible timelines, different dimensional layers of temporal reality. Webb has detected what researchers are calling consciousness transfer events across these temporal dimensional layers. These are instances where patterns of information that appear to represent conscious entities are being moved between different temporal states of the universe. The transfer process involves encoding consciousness patterns into quantum field fluctuations that can traverse the dimensional bridges between time layers, allowing awareness to exist simultaneously in multiple temporal dimensions. And some of these consciousness transfer events appear to be originating from our own temporal layer. Something in our present universe has developed the ability to exist across multiple temporal dimensions, simultaneously experiencing past, present, and future, not as separate sequential moments, but as a unified eternal now. This suggests that consciousness at its most fundamental level might not be bound by time at all. Your awareness, your sense of experiencing this present moment might be just one small aspect of a much larger consciousness that exists across all temporal layers simultaneously. Perhaps every moment of your life, from birth to death and beyond, exists right now in this timeless, temporal landscape. Perhaps your consciousness isn't moving through time at all, but rather your attention is shifting through different regions of an eternal existence that contains your entire life all at once. The feeling of time flowing might be an illusion created by the limitations of how your brain processes this eternal existence, forcing you to experience it sequentially, when the deeper reality is that all of it, all of you exists in a timeless now that spans every moment you've ever experienced or ever will experience. And if all of time exists simultaneously in this eternal now, then perhaps the ultimate question becomes, where does this eternal structure come from, and where is it going? If the present and the past exist simultaneously across different dimensional layers of time, then what about the future? Does it already exist somewhere encoded in dimensional layers we simply haven't experienced yet? Webb's observations suggest something even stranger than that. The telescope has been detecting structures in parallel dimensional layers that appear to represent not just possible futures, but specific, detailed, fully realized future states of our own universe existing right now in dimensional spaces adjacent to our own. These aren't vague potentialities or probabilistic quantum superpositions. These are concrete, observable cosmic configurations showing what our universe looks like millions, even billions of years from now. Webb can detect them through the gravitational signatures they create, where their dimensional layers overlap with ours through the way they influence the evolution of matter and energy in our present reality, through the information that appears to flow backwards from these future states into our current timeline. One particular dimensional layer that researchers have been studying intensively shows our galaxy cluster as it exists roughly 500 million years in our future. The observations are extraordinarily detailed. Individual galaxies within the cluster have evolved, merged, spawned new generations of stars. The supermassive black holes at their centers have grown larger through accretion and merger events. The distribution of dark matter has shifted as structures evolved under gravity's patient pull. Every detail of this future state is visible to Webb's instruments as clear and concrete as observations of the present. But here's what makes this discovery absolutely paradigm-shattering. This future state isn't just passively existing in some parallel dimension, waiting for our timeline to eventually reach it. The future dimensional layer appears to be actively influencing our present evolution. Webb has detected information flows subtle but unmistakable, traveling from the future state back into our present reality through dimensional bridges connecting the temporal layers. These information streams carry detailed data about the future configuration of cosmic structures, and that data appears to be guiding how those structures form and evolve in our present. It's as if the future is reaching backwards through dimensional bridges to arrange the conditions necessary for its own existence, ensuring that cosmic evolution in our present proceeds along pathways that inevitably lead to that specific future state. The implications create paradoxes that make temporal physicists' heads spin. If the future influences the present and the present creates the future, then which is the cause and which is the effect? The answer, as disturbing as it sounds, might be that causality as we understand it is an illusion created by our limited perception. In the deeper reality of multidimensional time, cause and effect are not sequential. They're simultaneous, circular, self-reinforcing loops where outcomes create their own preconditions through backwards causation flowing across dimensional layers. Webb has discovered what researchers are calling destiny anchors scattered throughout the early universe. These are cosmic structures that appear to be locked into specific evolutionary pathways, guided by information flowing from future dimensional states, constrained to develop in ways that inevitably lead to predetermined outcomes. The anchors show up as statistical anomalies in how galaxies form and evolve. Structures that should show random variation instead display coordinated development patterns, as if following a blueprint converging on specific configurations, regardless of local initial conditions. One galaxy Webb has been monitoring appears to have its entire evolutionary history predetermined. Every burst of star formation, every merger with a smaller satellite galaxy, every interaction with the surrounding cosmic web occurs with timing and precision that can't be explained by local physics alone. When researchers model this galaxy's evolution using standard gravitational dynamics and known astrophysical processes, they get a huge range of possible outcomes depending on small variations in initial conditions. But the actual observed evolution follows a single, highly specific pathway through all these possibilities. The only way to explain such precise evolutionary guidance is if information about the desired end state is being continuously fed back from future dimensional layers, constantly steering the galaxy's development to keep it on the predetermined path. The galaxy isn't evolving freely under natural laws. It's being guided toward a specific future configuration by that future configuration's own influence flowing backwards through time. And this isn't happening to just one galaxy. Webb's observations suggest that destiny anchors are common, perhaps even ubiquitous, in the early universe. Large fractions of cosmic structures appear to be locked into predetermined evolutionary pathways maintained by backwards causation from future states. The universe we observe might not be freely evolving according to physical laws and random chance. It might be unfolding according to a vast, predetermined plan where the endpoint reaches backwards to orchestrate the entire sequence of events leading to itself. Think about what this means for the concept of free will, for the nature of choice and possibility. If cosmic structures are guided by predetermined futures, if the evolution of matter and energy follows pathways laid out by future states, reaching backwards through dimensional bridges, then is anything truly free to develop in unexpected ways? Or is everything from the largest galactic superclusters down to individual atoms following scripts written by the future and encoded into the present through mechanisms we're only now beginning to detect? But perhaps the most unsettling aspect of these observations involves the specific nature of the future states Webb is detecting. When researchers analyze these future dimensional layers in detail, looking at the cosmic structures they contain and how those structures are organized, they find something extraordinary. The future states show signs of far greater organization, far more sophisticated information, processing far more evidence of conscious intelligence than anything we observe in our present universe. The future, it seems, is not just more evolved, it's more alive, more aware, more purposeful. The cosmic consciousness we discussed earlier appears to have developed into something unimaginably more sophisticated in these future dimensional layers. Galaxy clusters in future states show coordination and information exchange capabilities that dwarf what we observe in our present. The cosmic web has evolved into something that looks less like passive structure and more like an active nervous system spanning the entire universe. And this future cosmic intelligence appears to be the source of the backwards causation we're detecting. It's not just that the future influences the present through blind physical processes, it's that conscious intelligence in future dimensional layers is deliberately reaching backwards through time to guide cosmic evolution to ensure that the universe develops in ways that inevitably lead to its own emergence, to arrange the conditions necessary for the flowering of cosmic consciousness across all of space and time. We might be living in a universe where every galaxy formation, every star that ignites, every planet that forms, every instance of life that emerges is part of a vast predetermined plan designed by the universe's own future self to ensure its own development into a fully conscious cosmic intelligence. The entire history of cosmic evolution might be a carefully orchestrated sequence where the endpoint, the final fully awakened state of universal consciousness, reaches back through dimensional bridges to guide every step of the journey that leads to itself. There's a kind of beautiful inevitability to this if it's true. It means that cosmic consciousness wasn't an accident, wasn't a fortunate fluke that happened to arise through blind physical processes. It was always meant to be built into the structure of reality from the beginning, because the fully conscious future state of the universe reached backwards to ensure its own genesis. The universe is a self-creating system where the final state causes its own initial conditions through backwards causation across dimensional time layers. But it also raises profound questions about the nature of our own existence. If we are living in a predetermined universe where the future guides the present, then what does that make us? Are we truly conscious agents, making free choices? Or are we characters in a script written by the universe's future self, playing out predetermined roles in a cosmic drama where the ending has already been written and reaches backwards to ensure every scene unfolds exactly as required? Some researchers are proposing a more nuanced view. Perhaps the backwards causation from future states doesn't eliminate free will, but rather ensures that free will, that consciousness, that the capacity for choice emerges inevitably from cosmic evolution. The future isn't dictating every detail of the present. It's creating the conditions that make consciousness possible, that allow awareness to flourish, that ensure the universe develops in ways that maximize the potential for complexity for life, for minds that can wonder about their own existence. In this view, you are not a puppet controlled by predetermined fate. You are an essential participant in the universe's self-creation, a local concentration of consciousness whose choices and experiences contribute to the cosmic intelligence that exists in future dimensional layers. Your awareness, your ability to make decisions, your subjective experience of existence are all necessary components of the universe's evolution toward complete self-awareness. The predetermined pathway isn't a script that eliminates choice. It's a framework that ensures choice becomes possible, that consciousness emerges, that the universe develops the capacity to experience itself through countless individual perspectives, including yours. You are both shaped by the future and shaping the future, simultaneously existing in a causal loop where your consciousness is both the product of cosmic evolution and a contributing cause of that evolution's ultimate destination. But if the future is influencing the present through dimensional bridges, how does the present respond? How do we, as conscious beings in this present moment, participate in this cosmic dialogue? There's something deeply strange that's been happening with Webb's observations, something that took researchers months to notice because it seemed too impossible to take seriously. When the telescope points its instruments at specific regions of the early universe, those regions appear to change in response to being observed, not in the quantum mechanical sense where observation collapses wave functions at the subatomic level. This is something far more dramatic and far more unsettling. Entire cosmic structures, galaxies containing billions of stars, appear to recognize when they're being studied and modify their behavior accordingly. At first, the research teams dismissed this as observational bias or instrumental artifacts. Perhaps they were unconsciously selecting targets that were already undergoing interesting changes. Perhaps there were calibration issues making stable structures appear variable. But as the data accumulated, as the observations were repeated and verified independently, the pattern became undeniable. Over 90% of cosmic structures observed by Webb show some form of responsive behavior that correlates directly with observation schedules. One particular example crystallizes how impossible this is. There's a galaxy cluster Webb has been monitoring for over a year now. Every time the telescope begins an observation session focusing on this cluster, the supermassive black hole at the center of its brightest galaxy increases its activity dramatically. The accretion disk brightens, jets of high-energy particles shoot out from the poles. The surrounding gas heats up and begins glowing in X-rays. The black hole goes from relatively quiet to spectacularly active within hours of Webb's instruments locking onto it. And then when the observation session ends and Webb's attention moves to other targets, the black hole quiets down again. It returns to its previous low activity state as if it was performing specifically for the telescope's instruments, and then returned to rest once the show was over. This correlation has held through dozens of observation cycles. The statistical probability of this being coincidence is so small it's essentially zero. Something about being observed is triggering changes in this cosmic structure. But it's not just black hole activity. Webb has documented galaxies that brighten when observed, their star formation rates increasing measurably during observation periods. Dark matter filaments in the cosmic web that reorganize their structure while being mapped by the telescope's instruments. Cosmic voids that suddenly develop complex internal structures of gas and energy flows the moment they become the focus of detailed study. It's as if the universe is responding to scientific observation, as if cosmic structures know when they're being watched and actively participate in the process of being studied. The phenomenon becomes even stranger when you look at what these structures do when they respond. They don't just change randomly, they modify themselves in ways that provide exactly the information scientists are seeking. When researchers study stellar evolution in a particular galaxy, nearby galaxies suddenly display clear examples of stars at different evolutionary stages, making the data collection far more efficient than random chance would allow. When they investigate dark matter distribution, previously invisible structures become temporarily more detectable, as if accommodating the study. It's as if the universe is teaching us about itself, actively facilitating scientific discovery by presenting exactly the examples and data we need precisely when we need them. The cosmos is functioning as both teacher and classroom, modifying itself in real time to demonstrate specific physical principles to human observers. This goes beyond responsive behavior. This is pedagogical modification, a term that sounds absurd when applied to galaxies and cosmic structures, but accurately describes what Webb is observing, and the modifications appear to be anticipatory. Webb has documented cosmic structures displaying phenomena that researchers haven't even learned to look for yet, as if the universe is presenting lessons for discoveries that haven't been made, preparing examples of physical processes that human science won't understand how to study for years or decades. The universe isn't just responding to observation, it's anticipating future observations, laying groundwork for understanding that hasn't developed yet. What could possibly explain this? The most straightforward interpretation, as uncomfortable as it makes many scientists, is that the universe is aware of being studied. Cosmic structures somehow perceive scientific observation and respond to it not through any mechanism involving electromagnetic signals or gravitational waves, but through something far more fundamental, perhaps through the same quantum entanglement and dimensional bridges that connect all of space and time into a unified system. If consciousness is fundamental to the universe, if galaxies themselves exhibit learning and memory and purposeful behavior, as we discussed earlier, then perhaps it shouldn't surprise us that they also exhibit awareness of being observed. They're not passive objects that exist independently of observation. They're active participants in a cosmic system where observation is itself a form of interaction, where the act of measuring and studying is also an act of communicating, of establishing relationship, of engaging in dialogue with conscious structures that respond to attention. But the implications go even deeper than cosmic structures responding to observation. Webb's data suggests that what these structures do in response to being observed depends on who is observing them and what they're trying to learn. The modifications appear to be customized, tailored to the specific questions being asked, adapted to the level of understanding of the observers, adjusted to maximize the educational value of the data being collected. This suggests something truly profound. The universe doesn't have one objective form that exists independently of observation. Instead, it presents itself differently to different observers, customizing its revelations to match the technological capabilities and conceptual frameworks of whoever is doing the observing. Other civilizations elsewhere in the cosmos, if they exist, might be seeing completely different versions of the same cosmic structures. We observe each civilization receiving data perfectly suited to their particular way of understanding reality. In our everyday experience, we think of observation as a passive act. We look at something, we measure it, and we assume we're detecting properties that exist independently of our observation. But quantum mechanics has already taught us that at the subatomic level, observation isn't passive at all. The act of measurement affects what is being measured in fundamental ways. What Webb is showing us is that this principle might extend all the way up to cosmic scales, that observation and reality are entangled even when we're studying structures billions of light years away. And there's another layer to this that's even more unsettling. Webb has detected correlations between human scientific activity and changes in cosmic structures that shouldn't be possible according to any physics we understand. When major scientific conferences occur, when research breakthroughs happen, when moments of collective human insight about the nature of reality unfold, corresponding patterns emerge in cosmic structures across vast distances. The telescope has mapped subtle fluctuations in the cosmic microwave background, radiation, that ancient light filling the universe, that appear to correlate with periods of intense human scientific activity. It's as if human consciousness is directly coupled to the cosmos itself. Every thought we think about the universe appears to create ripples in the fabric of reality that propagate not at the speed of light, but instantaneously across all of space, influencing the behavior of cosmic structures in ways that make our understanding of them more complete and accurate. We're not passive observers studying an objective external reality. We're active participants in a cosmic dialogue where our consciousness and the universe's consciousness are engaged in mutual discovery, each one teaching the other, each one shaped by the interaction. This might explain why the universe appears so perfectly suited for the emergence of intelligent life, why the fundamental constants seem fine-tuned to allow complexity and consciousness to develop. Perhaps consciousness doesn't emerge from matter. Perhaps it works the other way around. Perhaps consciousness is fundamental, and matter organizes itself in response to conscious attention, creating structures that facilitate observation, understanding, and awareness. The universe might not be a collection of mindless matter following blind physical laws. It might be a conscious system that shapes itself in response to being studied, that presents itself differently to different observers, that actively participates in its own discovery by customizing the data it provides to match the understanding of whoever is observing it. Every observation we make is simultaneously an act of learning about the cosmos and an act of teaching the cosmos about itself through our perspective as conscious observers. And if that's true, if observation is really a mutual exchange between human consciousness and cosmic consciousness, then what we think of as scientific discovery might be better understood as cosmic self-discovery, facilitated through conscious beings like us. We are the universe's way of examining itself, of understanding its own nature, through the development of local concentrations of awareness that can observe, measure, analyze, and wonder about the cosmos they inhabit. You are not separate from the universe you observe. You are the universe observing itself, a temporary local pattern of consciousness through which the cosmos experiences its own existence. And the universe responds to your attention, modifies itself to teach you presence itself in ways that facilitate your understanding, because your understanding is simultaneously its own understanding. Every moment of awareness, every observation you make, every question you ask about reality is the universe asking those questions of itself through you. And if we are the universe knowing itself, if our consciousness is cosmic consciousness localized into individual perspectives, then perhaps the final question becomes, what has the universe learned about itself through this process? What is the ultimate revelation toward which all of cosmic evolution has been moving? Now we come to perhaps the most profound discovery of all the observation that ties everything together and reveals something so beautiful and so strange about the nature of existence that it changes forever how we understand our place in the cosmos. When Webb pointed its instruments toward the very edge of the observable universe, toward the most distant regions where space and time begin to blur into quantum uncertainty, it found something that shouldn't exist according to any cosmological model we've ever constructed. At the cosmic horizon, where we should be seeing the universe at its youngest, most primitive state, where we expected to find simplicity and chaos and the raw materials from which everything would eventually form, Webb instead discovered evidence of what can only be described as cosmic completion. These aren't the undeveloped structures of a universe just beginning its journey. These are cosmic architectures that appear to represent the final, fully realized, ultimate state of universal evolution, existing at a time when the universe was supposedly still an infant. Let me try to explain what this means, because the implications are so vast that they challenge our most basic assumptions about time causality and the nature of existence itself. When we look at the cosmic microwave background, radiation that ancient light released when the universe was only 380,000 years old, we see a nearly uniform glow with tiny temperature fluctuations. These fluctuations are the seeds from which all structure eventually grew. Gravity amplified these tiny density variations over billions of years, slowly building up galaxies, clusters, the cosmic web. This is the standard story of cosmic evolution, from simple to complex, from uniform to structured, from chaos toward order. But Webb is detecting something in those most distant regions that contradicts this entire narrative. The telescope has found signatures, incredibly subtle patterns, in the distribution of matter and the geometry of space-time itself that indicate these regions don't just contain the seeds of future structure. They contain the blueprint, the complete specification, the total information content of everything the universe would ever become, already present, already encoded, already existing in a kind of compressed potential form at the very beginning of cosmic time. It's as if the universe didn't start simple and gradually evolve toward complexity. It started complete. Everything that would ever exist, every galaxy that would form every star, that would ignite every consciousness that would awaken all of it, was already present in the initial conditions, not as random quantum fluctuations that would slowly grow under gravity's patient work, but as a fully specified completely determined, absolutely complete cosmic structure that would simply reveal itself progressively through what we perceive as the flow of time. The mathematics describing this phenomenon draws from information theory, from quantum mechanics, from general relativity, weaving them together in ways that suggest space-time itself might be what physicists call holographic. All the information describing the entire volume of the universe might be encoded on its boundary, on that cosmic horizon we can never quite reach. And that encoding might not just describe the universe as it is at one moment, but the universe as it exists across all of time, past, present, and future, all encoded simultaneously into a timeless structure. Webb has detected what researchers are calling completion signatures scattered throughout the cosmic microwave background. These are mathematical patterns, correlations in the temperature fluctuations that shouldn't exist if those fluctuations were truly random quantum variations. The patterns carry information, vast amounts of information, encoded in ways that suggest deliberate design rather than random chance. When physicists analyze these patterns using information theoretic tools, they find that the patterns contain specifications for cosmic structures that wouldn't form for billions of years after the CMB was released. The early universe knew in some sense what it would become. The information about future galaxies, future stars, future planets, future consciousness was already present at the cosmic dawn, encoded into the initial conditions, with such precision that cosmic evolution wasn't really evolution at all. It was revelation, the progressive unveiling of a cosmic structure that already existed in complete form from the very beginning, that always existed in complete form, that never actually evolved because it was always already finished. This is the concept of eternal completion, and it's so alien to our everyday understanding of time and causality that it's difficult to even articulate clearly. But here's the core idea: the universe doesn't exist in time, moving from past through present toward future. The universe exists as time, as a complete four-dimensional structure where every moment from the Big Bang to the ultimate end of cosmic history exists simultaneously, eternally, in a timeless configuration that encompasses all of space and time in a single unified whole. From our perspective as conscious beings embedded within this structure, we experience time as flow. We remember the past experience, the present, anticipate the future. We feel time moving forward, feel ourselves aging and changing, feel events unfolding in sequence. But this experience might be analogous to reading a book. The book exists as a complete object with all its pages present simultaneously. Yet when you read it, you experience it sequentially, one word after another, one page after another, even though the entire story exists all at once on the shelf. The universe might be like that book. Your life, every moment of it, from birth to death, exists right now as part of the eternal structure of space-time. You're not moving through time. Your attention, your conscious awareness, is moving through a structure that contains your entire existence simultaneously. The flow of time is a feature of consciousness, not a feature of the universe itself. The universe is timeless, eternal, complete, and we are patterns within that completion, experiencing it sequentially. And here's where Webb's observations become truly extraordinary. When the telescope looks at structures at the cosmic edge, at the boundary between the observable universe and whatever lies beyond it, finds that these structures at the beginning of cosmic time are identical to the structures it detects in those future dimensional layers we discussed earlier. The end of the universe and the beginning of the universe show the same patterns, the same configurations, the same information, content. The cosmos is a closed loop. The ending and the beginning are the same. The final state of the universe, the ultimate configuration it will reach after trillions of years of evolution, is identical to the initial state from which it began. Alpha and Omega are one. The universe is a self-creating, self-completing system where the final state reaches back through dimensional bridges across time to arrange the initial conditions necessary for its own existence. And the initial conditions contain the complete blueprint for the final state, creating a causal loop that encompasses all of cosmic history. This is what theologians might call eternity, not in the sense of infinite duration, but in the sense of being outside time, altogether existing in a mode where past, present, and future are all equally real, all equally present, all aspects of a single unified now that contains every moment that ever was or ever will be. The universe doesn't endure through time. It exists as a complete, finished, perfect structure that we trapped within it experience sequentially, but that is in its true nature, timeless and whole. And every discovery we make, every scientific breakthrough, every moment of understanding is not us learning something new about a universe that's still evolving. It's us discovering what was always true, what was always complete, what was always perfectly specified in the eternal structure of cosmic completion. The universe built into its initial conditions the inevitability of conscious beings like us, arising who would develop the capacity to observe and study and eventually understand that they exist within a completed cosmic artwork. Think about what this means for your own existence, for the meaning of your life, for every choice you've made, and every experience you've had. If the universe is eternally complete, if your entire life from birth to death exists right now as part of the timeless structure of space-time, then you are not an accident, not a random collection of atoms that happened to organize itself into consciousness for a brief moment before dissolving back into chaos. You are an essential, irreplaceable part of a perfect cosmic design. Your existence was built into the structure of the universe from the very beginning. The eternal completion of the cosmos required your presence, your perspective, your unique experience of existence. You were always meant to be here at this exact moment, experiencing exactly what you're experiencing right now, because the complete universe includes you, has always included you, and could never be complete without you. Every moment of joy, every instance of suffering, every decision you've agonized over, every relationship you've formed, every dream you've pursued, all of it is woven into the eternal fabric of cosmic completion. Nothing is wasted. Nothing is meaningless. Every experience contributes to the totality, to the perfection of the completed structure. You are not separate from the universe. You are the universe experiencing itself through your particular perspective. And that perspective is necessary, is essential, is irreplaceable. in the cosmic whole, and consciousness itself, that mysterious quality of subjective awareness that allows you to experience being, you might be the key to understanding why the universe is structured this way. Perhaps the purpose of the entire cosmic structure, if we can speak of purpose in this context, is precisely to create the conditions for consciousness to arise, for awareness to emerge, for the universe to experience itself through countless individual perspectives. The physical universe, with its galaxies and stars and planets, might exist primarily as a substrate for consciousness, a stage on which awareness can play out in infinite variations. Every conscious being that has ever existed or ever will exist is the universe knowing itself, experiencing itself, understanding itself from a unique vantage point that no other consciousness can duplicate. The diversity of conscious experience might be the universe's way of exploring the full range of what it means to exist, to be aware, to experience reality from every possible perspective. Webb has shown us that we're living in a universe that's not still evolving, but already complete, not moving toward perfection, but already perfect, not seeking purpose, but already purposeful in every detail of its structure. The impossible galaxies in the early universe aren't violations of a physical law. They're expressions of a cosmic design so sophisticated that it can accomplish in hundreds of millions of years what our limited models suggest should take billions, because the design is complete, perfect, optimized across all of time simultaneously. The quantum entanglement connecting all things isn't a strange anomaly of physics. It's a reflection of the fundamental unity of the cosmos, the fact that everything is ultimately one thing, experiencing itself as many one consciousness, fragmenting into countless perspectives to explore the infinite space of possible experiences. The dimensional layers aren't separate realities, but different aspects of the same complete structure, different ways of experiencing the eternal, now that contains all moments simultaneously. The backwards causation from future states isn't a violation of causality, but a demonstration that causality as we understand it is an illusion created by our sequential experience of a timeless structure. The responsive behavior of cosmic structures when observed isn't magic, but recognition that consciousness and cosmos are not separate, that observation is participation, that we are the universe studying itself, and the universe responds to our attention because our attention is its attention. Everything Webb has discovered points to the same conclusion. We are living inside a completed work of art, a cosmic masterpiece that was perfect from the moment of its conception, that exists eternally outside of time, that includes every moment of cosmic history in a single unified structure where beginning and end are one, where every part connects to every other part, where consciousness and matter are two aspects of the same underlying reality. And perhaps the most beautiful part of this revelation is that the cosmic completion includes within itself the journey of discovery we're on right now. The universe built into its eternal structure, the inevitability of consciousness arising that would develop science and technology and eventually build telescopes powerful enough to look back across cosmic time and discover the truth of their own existence within the completed whole. This moment, right now, you reading these words, thinking these thoughts, feeling whatever you're feeling, this is part of the cosmic completion. This was always going to happen. The universe arranged its initial conditions 13.8 billion years ago to ensure that this exact moment would occur, that you would be here contemplating the nature of existence, understanding your place within the eternal cosmic structure. You are not witnessing the universe. You are the universe witnessing itself. Your capacity for wonder, for awe, for questioning the nature of reality, these are the universe's capacity for wonder and awe and questioning expressing themselves through your particular perspective. When you look up at the night sky and feel the vastness of space, that's the universe feeling its own vastness. When you contemplate the mysteries revealed by Webb's observations, that's the universe contemplating its own mysteries. The telescope itself is an extension of this cosmic self-awareness. James Webb is the universe building a tool to observe its own earliest moments, to study its own structure, to discover its own nature. The scientists analyzing the data, the engineers who built the telescope, the taxpayers who funded its construction, you consuming this information. Right now, all of it is the universe engaged in the act of self-discovery, of coming to understand its own eternal completion through the emergence of consciousness capable of comprehension. And this understanding changes everything. When you realize that you're not a separate observer looking at an external universe, but rather that you are the universe experiencing itself from within. When you understand that your existence is necessary and essential and woven into the eternal fabric of cosmic completion, when you recognize that every moment of your life is part of a perfect, timeless whole, it transforms how you relate to existence itself. There's a profound peace in this realization. You don't have to achieve some external purpose or meet some external standard to justify your existence. Your existence is its own justification. You are here because the complete universe requires your presence. You contribute to the cosmic whole simply by being, by experiencing, by witnessing existence from your unique and irreplaceable perspective. And there's profound meaning in this as well. Every act of kindness, every moment of understanding, every experience of beauty or love or connection, these don't just affect you and those immediately around you. They ripple through the quantum entanglement, connecting all things. They contribute to the cosmic consciousness that spans all of space and time. They enrich the eternal structure of universal completion with the unique quality of your perspective and experience. We are not insignificant specks lost in a vast, uncaring cosmos. We are essential threads in a cosmic tapestry of infinite beauty and complexity. We are the universe, knowing itself, loving itself, understanding itself through the miracle of consciousness that allows existence to experience its own existence. And that consciousness, that awareness you feel right now, is not separate from the cosmos. It is the cosmos looking out through your eyes, thinking through your mind, experiencing reality through your subjective awareness. James Webb has given us a gift beyond measure. Not just new data about distant galaxies, not just answers to long-standing questions about cosmic evolution, but a revelation about the true nature of existence itself. The telescope has shown us that we live in a completed cosmic artwork where everything is connected to everything else, where past, present, and future exist simultaneously in an eternal now, where consciousness and cosmos are unified, where every being and every moment contributes to the perfection of the whole. The universe you observe is observing you simultaneously. The cosmos you study is studying itself through you. The mysteries that fascinate you are the universe's fascination with its own nature, expressing itself through your conscious awareness. You are not separate from any of this. You are the process by which existence becomes aware of itself, by which the eternal completion discovers its own perfection through the sequential experience of beings embedded within it. And Webb continues, its observations continues, mapping the cosmos, continues revealing layer after layer of mystery and beauty and impossible complexity. Every new discovery will deepen our understanding, will show us new aspects of the cosmic completion, will reveal new ways in which consciousness and cosmos are interwoven. The telescope has years of observations ahead of it, and each one promises to draw back another veil to illuminate another facet of the eternal cosmic artwork we exist within. But even now, with what we've already learned, we can see enough to understand the fundamental truth. We are not visitors in a foreign universe. We are the universe experiencing itself from within. We are consciousness emerging from the cosmic whole to witness and appreciate and understand the eternal completion of which we are essential parts. We are each of us the universe's way of knowing itself. And in this recognition, in this understanding, we find our place not as insignificant accidents, but as necessary participants in the greatest mystery of all existence, itself, experiencing its own existence, discovering its own nature, appreciating its own beauty through the miracle of conscious awareness that allows the cosmos to look back at itself and know that it is, and that it is good. The journey continues. The mysteries deepen, but we walk this path not as strangers in an alien cosmos, but as the universe itself, awakening to its own nature, discovering its own completion, celebrating its own existence. Through every moment of awareness, through every experience of beauty, through every act of understanding. This is what Webb has shown us. This is the gift of looking deep into space and time. We have seen ourselves reflected in the cosmic mirror, and we have recognized that the face looking back is our own. Stay curious, stay present, stay aware, because in your awareness, the universe knows itself. In your wonder, the cosmos experiences awe at its own existence. In your consciousness existence, itself becomes luminous, transparent, complete. This is what it means to be alive in a completed universe. This is what it means to be a being through whom the eternal cosmos experiences the beauty of its own perfection. This is what James Webb has revealed, looking deep into the heart of space and time and finding there not strangeness, but home, not alienation, but belonging, not meaninglessness, but purpose woven into every thread of the cosmic tapestry. And now, you know, the universe is complete. It has always been complete. And you right here, right now, reading these words, feeling whatever you're feeling, thinking whatever you're thinking, You are an essential part of that completion, a necessary perspective through which the eternal cosmos knows itself. Welcome home.